Hi, everyone. In today's lecture, we're going to talk about scientific notation. We'll learn how to convert a number from decimal form to scientific notation, and also how to go back from scientific notation to a regular decimal number. So, why do we even use scientific notation? Well, sometimes we work with numbers that are either really, really small or incredibly large, so large or small that writing them out in standard decimal form becomes inconvenient or even confusing. Let me give you an example. Imagine a tiny dust particle that has a mass of 7.53 nanograms. Now, if we convert that into kilograms, it becomes 0 point followed by 9 zeros, then 753. That's not easy to write, read, or use in calculations, especially in a scientific report where someone might have to count the zeros just to figure out how small that number actually is. On the other end of the scale, think about something enormous, like the mass of the sun. In kilograms, it would be 1,989 octillion. That's a 1 followed by 30 zeros. Clearly, saying or writing that number every time would be a nightmare. That's why we use scientific notation. It helps us express very large or very small numbers in a compact, readable format. Let's look at those two examples again, but this time using scientific notation. The mass of the dust particle becomes 7.53 times 10 to the power of negative 10 kilograms. The mass of the sun becomes 1.989 times 10 to the power of 30 kilograms. Much better, right? Now, here's how scientific notation works. A number is written in scientific notation when it's expressed as the product of two parts. First, a number k, where k is greater than or equal to 1, but less than 10. Second, 10 raised to a power, which we write as 10 to the power of n. So the general form is k times 10 to the power of n. For example, if k is 3.5 and n is 4, the number would be written as 3.5 times 10 to the fourth power. That equals 35,000. The exponent n can be positive or negative. If it's positive, it means the number is large, like thousands, millions, or even more. If it's negative, the number is very small, like the dust particle we talked about earlier. So to wrap up, scientific notation is a powerful tool that helps us handle extremely big or small numbers with ease. Instead of writing a number with a ton of zeros, we just use powers of 10 to keep things clean, simple, and accurate. In the next part of the lesson, we'll learn how to convert numbers into scientific notation and how to convert them back. Let's get started.